Okay, this video is very important to do correctly. Am I recording on yeah, performance, yeah. So I'm recording on a WAV script, WAV format, which is simple. Okay, okay. It's Siggy, N for November, N for November, S for Sarah, I for India, G for Golf, I for India, I for India, and Siggy. Human protocol. This video is on Rift. Rift is the festival translator. But especially the Rift toolchain ecosystem for building a compiler toolchain. This NSIGII, N November, S for Sarah, I for Indigo, G for Go, I for India, I for Kingdom, is a human rights protocol that can give you food, water, and shelter, and makes you become more sustainable. Makes you environment sustainable by the 10% factor clause. It is symbolic in expression and intent polls with tomographic language ambiguity resolution. Okay, the term symbolic here on the table here refers to the symbols, the identity of symbols. Symbols are in CBD, is influenced by NCBD. NCBD is the Igbo rooted language of Igbo. NCBD is root of Igbo. In SIGI, this protocol represents the foundation of NCBD as the root as well, but for human rights and sovereignty of the OB Nexus framework. The fact of the matter is, it is not, breathing is not optional, living is not optional, and being alive is not optional. Therefore, it must exist. The Human Rights Protocol for Sovereignty, and it's part of the Organization Framework and the Environment Policy, and 10% plus auto stable at all times, in all spaces and term, need to be stable at all times. Basically, it's a here and now protocol, here and now and here, not tomorrow, for today, for the time being, for the time we have here and now, for the space we hold here and now. And Insigi is making sure that no human gets taken. People don't get missing in Igbo land, and we don't know where we're going. But this is the first step to doing the protocol. This is not an ambiguous thing to do. But this has to define this problem. So the term symbol refers to CBD glyphs and CBD glyphs. The symbols can be engraved or etched. Symbol, so symbols can be engraved, etched, or written. Engraved with a what's it called, with a chisel, like the letter, written with a pen, or etched into stone with some kind of mechanical device that's used by a human tool, or wood, can be etched into stone. That's the definition of a symbol. A symbol is something that is etched, written, or written, etched, or written, etched, or chiseled. Into stone. So it's written or etched. It's written, etched, and chiseled. That's a very positive word. It's really engraved, written, or etched. That's the positive. It says engraved, written, or etched. And so Chile is one example. In Chile, the letter, the English alphabet, everything in English alphabet. In Chile, a lot, everything like that. But it's a consistent system. So what's the yes, no, and maybe? Maybe is a valid state. Do you need more time? Okay. For example, permission is granted to valid users, but the goal of this system of intent. So you get a trident pole. So you have a symbolic expression tree, and they have three expressions. So the symbolic expression tree refers to the self-balancing trees of the token, right? So the system at play. For example, in this video, I'll give you a example of French, Igbo, and English as one unified canonical language of expression and intent. Those two or three languages are trident languages, that we use to resolve a system based on the mechanical alphabetic form. You know, Igbo has 34 letters. English has 25, I don't know about, yes, English has 25 and French has 26 letters. No, English has 26 letters, French has 20. A, B, C, D, L, J. Uh, French has 26 letters of English alphabet. So this is a provision to model Cisco instruction set. C for Charlie, I for India, S for Sarah, C for Charlie, O for Oscar, which is a bottom up execution order for calculator system via Rift ecosystem. Rift represents Rift files, use regular expressions, and see via Rift bridge. So the Rift bridge meta files bridge and C sharp as one unified topographic language. The objective is to have a self-balancing tree that that has a self interpreter of language. You have three interpreters of I need food here and now. This I need food here and now is interpreted in Python in as as a compatible with three main top library targets. A French, English, and which is English. .fr Francais. .fr and .en, .ng for Nigerian Igbo, and Igbo.ng or Francis, French. Francis. But we also have a symbolic intent files. Symbolic expression, which is what the model of structure. So the expression tree has its own expression model for the target language because it's basically phonological observation of the state. I'm speaking French to you, you speak reply in French. I'm speaking English to you, speak reply in English. I'm speaking English to you, I speak to you. But this is how system resolves itself topographically. Okay, so how does this work? This is work by poles. A symbolic expression has its own pole, and this process can be dynamic or static. So the poles represent dynamic or static poles. For example, you have a peer-to-peer topology. It can be dynamically or static library. And those poles can be static or problem. So a dynamic system can evolve. A dynamic library can evolve. A static library is just a static system. So it's just one target to one system. And those are the files that's already working. So we have two main targets: static and dynamic via peer-to-peer topology. Localized topology. But the poles represent symbolic expression, such as the glyph of the utility, that have the glyphs of the utility, which are the dynamic systems. The glyphs are dynamic. They are dynamic, and glyphs are dynamic because they can mean it can mean something that's changing. Something that's open to change, or symbols that can change with time. With time, for example, you have the symbol of this symbol here. A small person holding a big person, indicates a child. You have A, E, I, O, U. You have A, E, I, O, U. A, E, I, O, U. But you have A, E, O, U. This is basically the Ebo, Asusu Igbo, or Ebo tonal format of Igbo. But we have 34 characters in Igbo. So we have all these vowels in Igbo. But these vowels are tonal. They're dericatic. They change the meaning of a sentence. They're vowels that change the meaning. For example, you have Eze. Eze. That means T. See the low tone on the E? That's a low accent here. Low accent. You get a high accent here. These are called accents. You go up and come down. So the E, sound E for echo, has a high accent. And then it comes down. You see it says, so say high to low tone. And you have low to high tone. Low to high tone. This one means king. The first one means Tito. That is my persona, my second persona, the king, you know. But it is not. It's not. It's a direct. It's a directive form. So to go to how this is called. This will be a glyph. This area will be a glyph, and this glyph will represent the kind of state of diacritic files that change based on tonal tones. Because you have two states, you have two tomographic states, two topological states to resolve, high tone and low tone. And you can get other glyphs as symbols. These are valid invariant, these are valid glyphs. But these are all symbols. So these are all standard symbols. The A, E, I, O, U. But those are just standard symbols. These are just called etches, what do you call symbolic intent. So called symbols. But they're all symbols, but certain symbols are called glyph. They're called glyphs. So they're just all symbols. One is a glyph, one is a symbol. I've got my paper here. So a rift is a physical translator or rift bridge. Bridges C++, and C sharp for NSIGII programming. Programming is bound to C spec, C a rift, and rift in C. Because rift in C, or github.com/obi nexus /rift. R for Romeo, I for Indigo, F for France, T for Tango stands for Rift is a fucking translator. Rift plays the roles with meta rift files. Files will ending with dot and MRF. N for Mike, R for Romeo, F for France. These meta rift files have have digital targets, and these digital targets can be dynamic or static, but it's basically how the system resolves stuff tomographically. So Rift represents a system of pattern matching over C construct. For example, you can match R colon A to Z A to Z and put a match the kind of diacritic some high tone light to give them the kind of frequency of the voice. Yes, the local interpreter. But similar interpreter has yes, no, and maybe can interpret yes, no, and maybe. Maybe is a valid state for the machine to compute from the heart. That's very important because all these are experimental politics are for linguistics of chemical understanding of a dimension of language. Example, speech is a natural language, but the system must understand compound and complex sentences, which is a system of dependent, one interdependent, one independent, one dependent clause, which is a compound sentence. That makes sense to me. It stands out because it's a command and control system. It basically works on the fly. On the fly. Rift metal files and Rift .rf files, Romeo France files, are Rift files, are standard files that use Rift to match that uses magic that matches all the header definitions of the Rift bridge ecosystem, which is basically the bridging of system. But the Rift files have the Rift files, so you have targets for languages too, but it's not just you. So you have Rifts can be extended to Python naturally because you get a riff.toml, and you have riff.json, and you have for JavaScript objects, you have but the target is specified by Rift. For example, you have silver.py. You can use the silver.py to include a Rift.toml file, which we will call a pattern environment. And this pattern file will work with a pip registry. Pip equals install package name via Rift interdependency framework. Now, the interdependency framework has its homographic resolution too for Rift, because NSIGII is written in Rift too. So how does this work? So Rift, the SIGI is a human rights protocol. On-the-fly verification is needed. But the goal is to have tomographic polar lattice on the fly. So the system has to verify that you have when you start, you have the time and space allocated, and then it's on the fly. But it's always a lattice. A lattice, Alpha Lima, A for Apple, B for Papa, I for Indigo, F for is the world's first polar integral firmware. It's called a lapis. Lapis is taking derivative or taking integration over error, every pathway shape system goes. There has to be a pathway. But it's something that we on the fly verified. It works by ensuring that superposition and entanglement are working. But when it just times out, it's taking time clock. It has immunity because immunity has the space or time. The time and space it holds for that resource to be allocated and this to be done. So it's called a time capsule. And time equals x squared plus y squared equals t squared. And y squared equals the probability equation. And time is the Lorentz factor, which is basically the system of polar nonlinear systems of dimensions of dimensionless quantities. Now, dimensional quantities are basically what happen on one axis. For example, you have x, y, z. All the computation has on one axis, so there's no dimension to exploit, no buffer to take over and hold hostage via the time capsule. Thank you. So we have rift is a rift metal rift valves born from blood, sweat, and tears, such as polar axis. For example, you have 0, 0, 1. Now, 0, 0, 0 can be 1, 1, 1, 2, 2, 2, 2, 2, 2, 2. Rift stage 0, 0, 0 represents the early stage of rift. And this rift 0 is using a brand new rift valve in empty rift setup. Rift stage 000 represents your building, start building your Alexa. You're in epsilon state. You're doing nothing. You're in alpha state. You get reached to 111. Now, if you have 000, you have 111, you have minus 111. But the minus 111 are basically what's packaged here. What can you do? What's saved you can deploy and it works. Because Rift is tomographic has a stable state. So tomography, basically, it shows what's executed. You don't have to hold it. So minus 111 is Alexa state. So by encoding, so you get the vector 000, and if you have a 001, you've completed the first unit test. You completed the first tomographic. You completed the part. You are at stage one. You're now writing the. You now have the unit model verified. The main the C verification of the C spec, like matching ABC, matching the English, Igbo, and Igbo, Ebo, or Igbo, and English, Igbo, and French as one language, which of you are matching in C, in C, in C, in C, in C, and then on C++, in C, without bridge in C, in C or C++ or C sharp. That's the goal. So the goal is to have the system resolve itself by one target language, and that's the target language. You can have other targets developed, other target language, but this is just stage one. This is Alexa stage one, but you get lift stage 001. So you get the unit model working. Now, lift stage 2, 1, 1, 0, so like 011 is you get the integration working. You get two or more modules, and two or more modules as a package. Two or more modules as a package. You can have one single file run in C file, C++, and C sharp file run, but this is not tomographic. This is just one file. So you can package that to 001, and this will be -1, 2. But the state has to resolve itself, so you can't lose an artifact while you're working on it. So if you have if you have 011 and you wish to deploy it, it's already saved as -11, minus epsilon 11 or -011, minus 0 minus basically minus 11. Basically, the state tomographic state 11 has -11, and that -11 is held by you. You don't have to hold that space in them. You just have that thing saved. So whenever you lose your work, if you go to stage 111, which is actual Alexa, you have built a full lesson Rift, and the Rift can open a file based on any polarity, any polarity of the endiness. Now, the endiness represents the Cisco endiness, basically what left shift endiness, right shift. We have execution, and you have Cisco endiness, which is bottom up position, and risk instruction is top down execution. But Cisco and risk are which is just refers to assembly instruction set that resolve self-balancing trees of read write execute permission to open the artifact. For example, if I have 011 and I'm reading from the left, I am reading 110. What's reading from the right? 110. A computer can only execute one order at a time if it's not polar. It's not polar, so you cannot read two. You have to get two. So you have to 011 on the left ending machine is a different meaning to 110, and the computer doesn't know how to start the sequence of instruction using self-balancing trees. So essentially an all modeled over self-balancing red black trees. but the axis has to be determined ahead of time, and what is the matrix and the vector has to be determined to determine the grid space over 2 pi r and 180 over 180 and pi r squared over 280. Then you get to root phase 2 is 222, or so 202 would be, or 212 would be, 212 would be the particle problem. So you get 212, but you get ambiguity there. So you get so if you it's just based on the energies of your machine, it's not energies of your machine. That's basically what results got. So which the 212 presents if the right mode, if the least mode bit is the least again, if the right mode is the least, if the right mode bit is we get 212, and 212 was the artifact of Lex of Parson. 212 represents Parson. Parson one module would see Parson writing executable or circular with a parser something that can be part of a natural language artifact, like symbolic instruction, or pattern artifact, so it can be part of an interpreter. But this part of it is in TriPoles model. This is where the symbolic expression intent model comes in. Now, the symbolic intent model work on stage with 222 and 212 represents the parser has worked and integration test has worked. You're happy with the testing of the parser. You've written one test, you've written one unit model, one test, and your all package. That's the minimum requirement. Using one test and one package. That's with 2-1. If you have 2-1, you have one unit model and one test. No test. But you have the pollen test as other ones. You have 2-1-2, and you are now deployed. You are now packaging. So root 1-2 is packaged. You got your local copy. Now the local copy of yours is peer to peer. So you have the package saved as again, but this is your pointer 2-1-2. So you can now move on to stage 3, which is the abstract stage. So you can have the abstract stage. You can start building after EST. So the EST it is based on the execution order, which is basically the symbolic expression down on the parser stage. What's the meaning of the triangle? If it's not down on stage 2, and you make a mistake, which I'm saying you would, stage 2 of ref tomographic parser will show minus pi to pi for resolution, but this basically works on pi over 4, pi over 4 for north, pi over 2, 3, 4 east, pi over 2 for south, and pi over 1, or just pi west. The sum of the intersystem was the same. So the goal is to have a tomography system that resolve 3 main stages, and you can get more stages ahead of time, and if you have one more encoding to do, you can have that as a system of stage of priority. So you have 4 numbers. You have a priority encoding sequence. Where, you get three different hits. You get one priority. So you can have 4. You can have 3, 2, 1, and 1 and 5. I know 3, 2, 1, and another row station. You can define that in the schema how you want it to do. You don't have to use this encoding. The schema is what the tomographer use. You can have your own schema too. Just make sure you don't break the schema you define for the tomographic layer. That's what you said. So which stage 3 to 3 is the parser stage, and for the AST, and the AST is actually the intent of the Cisco system. Cisco stands for Cisco instruction set, but the instruction set is actually bottom up Illyrium or top down bottom up Hamiltonian, based on the target language of the natural language character using self-balancing trace. The goal is to have a consistent framework that has a peer-to-peer network tomographic layer that maps out as a plan of system. And say, and yes, so this is really what I'm saying. As you can see here, there's a lot of work I did here, but I'm doing a side I can't see you. So the very frequency is £10,000 while lost homeless. So that's when you get to you have to put it with your human rights to download to use the NSIGII protocol. To download the NSIGII program, you have to use it's a litigation system. You cannot get the NSIGII protocol if you don't have human rights complaints. You have to have some kind, just have £10,000 up to litigation or to to download to have the NSIGII protocol. Download it so you can download Miko OS. Now, NSIGII protocol is a human resources verification. So I lost £10,000 homeless from the 29th of November to 28th of January under the Health and Security regime. For Cambridge University. I had the money. I saved it for PhD for 2 years, and I lost that investors. I paid £262 per week, and for 1.5 months, and £262 per day at Premier Inn. I lost the money because I was living in a care house. So £10,000 we need to have for litigation if you need anything. Which is really anything, but litigation is basically the law of solving problems based on human from you don't buy this. You just need to have 10,000 or less. But we can support you with anything you want. So this is what we want everyone to do. This is financial stability baseline for everyone should be having for the human rights. Because the human security can give you food, give you water, give you security, and peace of mind. That's the goal of this project. It's basically give you security, give you feed you, to feed you, or feed your children, to buy milk, can order stuff, when you're away from the computer, when you're not, when you're in your house, you can order to keep fit, keep fit as well. It tells you to keep fit and do exercise, and get along with the day. Can help you organize your life, based on your human rights framework, and make sure you have space to do, you organize your space to do things you want to do. You know what I'm saying? That's what human is about. So the human rights protocol is here and now. What they're doing here and now forever. To stay on this protocol. Because if bread gets moldy, it becomes stale, and you cannot eat it anymore. So it keeps on. So it's basically to keep the protocol alive for you. That's what 10,000. Because I lost that money, and the sustainable for me to go to my PG and credit for a buy a house. So you have to get up to this money, 10,000. But it's best to just get the money. If you're a good ledger on the blockchain, or particularly a blockchain system, and you can get some, you can keep your baseline, and you should get more money for other things. But 10,000 GPD, Great British Pounds, is what the Human Rights Protocol requires. For you to download Miko OS with NSIGII, and for Mike, you from K for kilo of OS. Yes, and you get the colors here. So the symbols are interval here with no animation. No animation is it's a symbol, not a zero. It's a type of symbol, but it's not a full G. So last but not least, we have this one here. So as you can see here, this is basically sliding block problem. So we have a block, let's say 10 units away from the wall, 10 units away from the wall. That's like 10 centimeters. 10 units away. You have another block 20 units away from the first block. So you have a total of two blocks that are one. So you get the square block, which is basically a square block, which is width times height, base times height, base times height. This is basically a square block. This square block represents the kind of system of computing power. This is called it's actually one problem to do. I was trying to compute pi with this kind of system, but using around risk matching. So pi will give you an estimation of a structure. Will give you a structure that is basically when the so you get 8 times 8, which is a block, one block. You get 16 times 16, which is the biggest block on the other side. So these two blocks, so you get one, which is 20 meters away, and you get the one 10 meters away, 8 by 8, and that basically 8 by 8 will give you 8 times 8. So they have 8 times 8, 64. 64 area, 64 units squared. 60 squares. 64 centimeters squared, and centimeters is units, and you get it being 10 units away, or 10 centimeters away. You have the 120 meters away, which is 16 times 16, which is like 256 centimeters away, 256 centimeters away, centimeters away, 256 centimeters area away, in area. So the goal is to have the big blocks slide into the small block, and keep to slide into the small block until with no friction, until the big block moves away. You'll notice that there's an oscillation between the speed of the blocks, as it hits the wall, and the wall is basically make it slide away with the no friction principle. Because this will compute 3.1415 pi to a good amount of decimal places to keep the matching system going. But this protocol is basically resolving kind of a tomography state of computation. Applications include computing something ahead of time using a model that's already there. And you get the beautiful needle, which computes pi based on double the length of axis, double the length of the system, double the height and of the needle, which is double the height, which is basically double the height of the needle. And this paper is 3 centimeters needle to needle length, and basically the meters is 1.5 centimeters. So you have two in height. You have an axis in height, which is the y-axis, 2 L divided by d, where d is the distance needed to be traveled for the needle. So if you think about d as distance traveled, and you have 2L, which is the length of the height, in the y coordinate system. That's what we're doing. So this is 3 centimeters. You get the need is 1.5 centimeters to match up to the line. But horizontally, this basically computes to 4%, 4% in ratio. You know what I'm saying? So 2L length of the height divided by d, which is the needle width and height, gives a product 64%. 64%. The 4% is the goal of frame for compute power, and this can be used to the substructure model to ensure tomographic resolution and necessity mitigation for the system principle and resolve the system via tomography intent. So without further ado, I'm going to try to read out some one more thing. So here we have alphabet English alphabet A, B, C, D, E, F, G, W, H, I, J, K, L, M, N, P, Q, R, S, T, Y, W, U, V, W, X, U, V, W, E, Y, Z. So I'm just reading the French alphabet, but the French alphabet is just because you go to the A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And you got the Igbo alphabet. You go back to basically A, B, C, D, E, F, F, G, W, H, I, W, W, I, I, U, L, V, Z, V, W, Z, J, Z, Z, and that's basically the English, the Igbo alphabet that we've recited. But these three alphabets are characterized, have symbolic intent, they can have intention, and they can have action too. And intention is basically what the Cisco model does. Cisco is basically models bottom up as a priority. So the polar priorities are the poles, and you can have a pole from one axis, and the one axis is basically Z, based on the dimensions of the dimension precisely the principle of dimension of language. How language is perceived. How language is perceived. What gives you language? And the important thing to understand is it's not about language perception per se, it's about the principles that language share. So language is understood from an angle, from a foreigner. What is a layman language? So the arbitrary requires to show you that it does work. I am bilingual, and to show that it can work. So if you have a top-down resolution, you have a Z, Y, X, A to Z. If a bottom will get Cisco, bottom starts with Z, Y, X, W, V. So that's what Z stands for. So the bottom starts with the Z, and that's what Cisco. Cisco is the standard way to power the system for all general language, for all the chemical states, all the space bar, all the breath pauses, But the goes to capture the nuances of the language and categorize that into the framework of rules. And the rules represent the dimensions that can never break it, such as what is the Hamming code, and that can be coded via the dimension of language and the principles of language that can never change. What's the rules of language and the rules represent dimension principles or dimension principles that help with language. So the system can know the cure here when parsing natural language. Thank you guys for watching. The time now is 9:52 p.m. where I'm at. Have a lovely day and good night. This is the 3rd of January 2026. Thank you for watching this video. If you did watch it.